Okay, what we're going to do now is we're just going to look at solubility and, let's say, insolubility. Okay, why are some things soluble and why are they not? We're not going to be looking at the whys. Well, the whys we've said, if the molecular force between the polar molecule of the solvent is the stuff that's dissolving it, right? So, for example, thinners is a solvent, right? What we do is we're saying that if those forces are not big enough to pull all the other bits and pieces off, then it won't dissolve, all right? But we know that things like sodium chloride, etc., dissolves. What we have to do is you've got various tables, and I've got one here. I'm pretty sure there's one on the download section, but it tells you what is soluble and what's not, all right? So if we've got group 1 and ammonia, okay, they are all soluble. Sulfides, oxides, sulfates, carbonates, hydroxides, nitrates, chlorides, bromides, and iodides, okay? So for example, group 1, okay, and lithium, that's lithium, sodium, potassium, and ammonia, those are all soluble. So lithium bromide is soluble, okay? And this is in water, of course, right? Then we say group 2, magnesium, calcium, strontium, barium. They are all soluble except magnesium carbonate. None of the carbonates. This is a table you've got to look through. Now, how do we do this, okay? Essentially, it's an ion exchange thingy that's going to happen. Let us have a look. We put together sodium chloride, okay, and it's aqueous, and we add to it, let us say, silver nitrate, AgNO3, okay. Nitrate, now hang on, we've got to look, is that correct? Because what we've got here is we've got nitrate is, and I always remember it, I remember nitric acid, NO3, and an NO3 is -1. And silver is one of the ones we have to remember, is silver is a +2. So what have we got here? We've got 2. Okay? Now, let's say they tell us that that is solid, that we add that to water. What happens now? Now, when we add it to water, we have to split it up into ions. So what do we have here? We have Na plus Cl minus plus Ag plus 2 and plus 2 NO3 minus 2s, right? 2 of those radicals or 2 of those polyatomic ions. That's what's in the water. So we had this sodium chloride. Now remember, it's soluble. So what happens to those? Silver, let's check, silver nitrate, yes, it's soluble in water. What happens? It means that the water molecule, just to quickly go back, okay? Remember, this was negative, that was positive side, this was the O, this was the H. So it came along to this silver nitrate block, AgNO3 and this side here, this piece, this negative piece, said hello to those Ag plus 2s, and it broke them off. It sucked them out. The hydrogen, okay, was positive. The NO3, one maybe went there, and the other NO3 went there, right? So what happens here is that these hook onto the positive and negative side of a polar molecule, because these are ionic and this is polar. So it's soluble, okay? Now, that's how it goes, or rather that is what happens in the water. It's soluble, which means it forms ions in the water, okay? That's a given. So if it's soluble or aqueous is written there, this means here it is dissolved in water. It is aqueous. What happens here? Now, what do? We say, right, we have got U as an ion. I'm identifying the 4 different ions. Okay, just give me a sec. And blue. Right. Now what do? We now go back and we say, okay, this is all in the water. What happens now? Now we look for an ion exchange. We go and we say, right, ion exchange. Why? What does it mean? The ion Na plus was connected to the Cl. Now we look to change. In other words, it's exchanging the Cl for that. Ion exchange, we identify from the first to the second, the positive to the negative one. Okay? So the anion, the cation to the anion, the metal to the radical or the polyatomic. So let's have a look. Then we go to our table and we say, right, sodium, and go down to nitrate, and we say sodium nitrate is soluble. And we say sodium nitrate, nitrate minus 1, sodium plus 1. So that's going to work just like that. It's a 1 and a 1, isn't it, like that? Okay? Do you see what I've done there? The sodium is a plus 1, the nitrate is a minus 1, right? So you can see that now. All right? So what's next? Okay, let's get rid of that. And you don't need that bracket here, guys. I just want to tidy it up. Sorry, let me just fix it nicely. NaNO3, right, like that. Now what's the next? The next is then we say, well, then these two must get together, and we say AgCl. Ag is plus 2, Cl is minus 1, so there's 2 Cl's, right, in there. Remember, can you see those valencies, how critical they are for this? If we don't know the valencies, what happens here? We are, boom, down. So let's have a look. Right, we've got that. Now we say, is this soluble? Soluble, yes or no? Okay, let's have a look. We say sodium, there's group 1, and it's a nitrate. Yes, it's soluble. So therefore, we now can go up to here and we say aqueous. Okay? Now, what about silver chloride? We look silver, no. So that forms a solid. What does it mean? Okay? It's not soluble. If something's not soluble, what does it do? In the water, we've now got NaNO3, like that, soluble, and this stuff goes and forms a powder at the bottom. It precipitates out. Okay? So it precipitates out. To precipitate, rain is precipitation. It's water vapor that turns to a liquid and falls. It's vapor, it's a gas in the cloud, right? Tiny, tiny droplets, not quite a gas, but tiny droplets, they get together and fall. It precipitates. Snow is precipitation. So these fall out of the sky, they are precipitation. Okay? What happens if we mix things together? We have to check if there's a precipitate. Okay? That is what this is all about. It's about what is soluble and what's not. So let's have a look at a recipe. How do we go through this? Right. Basically, what do? We say, right, step 1. Okay? And forgive me, I didn't check the balancing of that equation. Write down the first substances, okay, added to the water. Okay? Well, let's take a different. Let's take calcium. No, let's take barium hydroxide. Okay, let's take barium hydroxide, BaOH. But now barium is in group 2, so it's got a valency of plus 2. OH is minus 1, so we need 2 of these to get to a minus 2, correct? I take everybody by now should be quite happy with that. All right, there we go. Oops, sorry. There's the BaOH2, right? And it's aqueous because we check on our table, Ba and OH, yes, that is there. Then we add to that, let's say we add copper chloride, Cu, let's say it's Cu2, okay, copper 2 chloride, okay, just let's make this, because that looks a bit like calcium, copper chloride, and we tell you it's copper 2, which means this is a +2. Remember, it could be copper 1, right? Copper 2 chloride. They would tell you like this. Copper 2 chloride. That tells you copper +2 Cl -1, which means we need 2 of them. Okay? Like so. Okay? By now, everybody should be more than comfortable with that. All right, copper chloride. And let me just check. Copper chloride, yep. Okay, copper 2 chloride. You are soluble, so I make you an aqueous solution as well. Now, we split the ions. We've got Ba, and barium is a +2. We've got +2 OH minuses. Remember, we're splitting it up. Copper was a +2, +2 Cl minuses, right? What happens now? Now we look for our ion exchange, right? First of all, that's our first one. Okay, you are my second one. You are my third one. Copper being green, that's pretty cool. Okay, because it does go green when it oxidizes on a roof. People think it looks lovely, a green sort of copperish roof. Right, now we do our ion exchange. So we take the first and add it to the anion, to the cation, right? And we take these. So let's have a look. Barium chloride. Barium, I need 2 chlorines because this is +2. I've got to make that a -2. Okay? Now I go and I check. Barium chloride. Yes, it's soluble. Okay? So I say soluble. Yes. No. Right? Write down and add it to the water. We've checked they are both soluble. Split into ions. Okay, that is step 2. Step 3. Do ion exchange. Which is what? First metal, first cation. So that's first cation, in other words, the positive ion, to the second anion, another negative ion, the negative, right? And then it's the second cation, in other words, the positive ion, to the first anion, which is negative. Let's put in, we say, this way, and then it's that way, isn't it? The first to the last, then this one to that one. Now let's have a look. Plus CuOH. This was a +2, so I need 2 of those, right? Let me just make this neater. Whoops. Okay, 2. Now I need to see, is this soluble or not? Okay, do ion and check solubility is step 4. Okay, step 4, check solubility of the new pair of ions, right? So first ion was soluble, right? We said barium, Cl2, soluble. Now we have to check for, we have to check for, the other one was, in this case, copper hydroxide. CuOH, remember we have to balance it. It was a +2, So that's going to be 2. Let's check. Copper hydroxide, no. It's insoluble. Okay? So therefore, what happens? Right? We get the copper hydroxide becomes a solid. It is going to precipitate out of solution. It's insoluble. It can't live in the water. So it precipitates out. Okay? That's what we do. We take the 2, we write them down, we check that they're balanced because they're going to give it to us in words, right? You've got your table. They don't give it to you, you've got to remember it, okay? They're going to maybe give you some hints or whatever the case might be. There are some tests as well, okay? Those are pretty much for students doing O-levels, A-levels and A2 levels in chemistry. They have to know all the tests. In fact, their final exam is comprised of practicals as well. So they'll be given unknown substances and be asked to find out what it is. You have to go through a certain range of tests, a certain gamut of tests to be able to establish, for example, that you've got a calcium hydroxide salt at the end of the day. Okay? Right, so now, that sorts that out. So those are ion exchange. What is happening? Right? These here, well, let me rather use 2 different colors here. Let's use a pink and an orange. How's that? Okay, here's 2 molecules. Okay, they're different. We put them in water. We then do this, don't we? They go into water, then they separate out into the different ones, like so. Then we take them and we check, are you soluble? Are you soluble? Yes or no? If they're both soluble, then there's no precipitate. That can also happen. You can also get it that they both precipitate out at the end of the day. All right? And you just get left with what you started with. But 2 different substances, okay, have precipitated out. So the first 2 you put in were soluble, but the new 2, these 2 there, but these 2 are not soluble. And they both come out. Neither one can come out either or both can stay in as a precipitate, as in solution, right? The last section here is redox reactions. Now, redox reactions are an entire, well, next year, it's an entire chapter on its own, okay? This is a process involving electron transfer. Right? It's a process involving electron transfer. What actually happens here, right, is this. Let us take this reaction here as the one that I'd like you to remember and write it down. This is copper sulfate aqueous. Okay? My apologies that my U looks like an A. Copper sulfate aqueous. Let's check. Copper sulfate, it's soluble in water. Okay? It's blue crystals and it dissolves in water and turns the water blue. So the color of this solution here is blue. Okay? It's actually a lovely blue. Copper sulfate turns it a really nice blue. Right. So this is blue. Okay? It's in water, which means what? It's dissolved. So it has formed ions. So we need to split it up. This is, in here we've got Cu plus 2 plus SO4 minus 2. Those are the charged particles floating around attached to the molecules of water. Remember, it's soluble, therefore the force is enough to pull the copper out and the sulfate out and basically break it down and dissolve it into the water. Now, that's great. Now, the next thing we do is we come along and we put a piece of zinc solid rod into there. Right? And we have a look what happens. if at all possible, try and write this one down and remember it, because this is pretty much what's going to happen with cells and oxidation reduction in grade 12, is this specific reaction I'm doing now. It's one that gets carried forward. So the quicker you look at it, understand it, the far easier 11 and 12 become when you look at this guy again. Zinc is a solid, okay? Now this is what happens. All of a sudden, we see, let's just see, the zinc dissolves, okay? And the water turns clear with brown specks precipitating out. The blue changes to brown, and we see little flakes of stuff in the water. What has happened? Do you remember grade 7, 8? They told you, they used a word at the time. Whoops, not that. They used this word. D-I-S-P-L-A-C-E. Displacement reactions. What are they? It means that the zinc took the place of the copper. It displaced it. What does that mean? Just look at this. Here's my soap on a rope, right? No, it's not used. This thing comes along and knocks it out. It takes its place. Displacement means takes its place, right? What has happened? The copper has precipitated out. The copper's been kicked out. The zinc comes along and says, no, cheers, go, get out. I am going to be the ion here, you go. You are now copper, okay? Critical, okay, critical, all right? Displacement reaction. Let's look what really happened, all right? What did we have? We put zinc solid plus copper sulfate aqueous, okay? And we noticed that we got copper solid plus the zinc was disappearing, so the zinc must have linked onto the sulfate, all right? Remember, zinc is +2, copper +2. Sulfate -2. What happens here now? Well, let's just look at separate reactions. What did the zinc do? The zinc solid changed to what? It changed to Zn+2. It dissolved. It went from solid to an ion, didn't it? That's what dissolution is about, isn't it? Remember, it's got taken out. So that's what happened. How did this occur? I'll get back to it. Let's have a look. We had also copper +2 ions. They were in the water, but now I've got a copper solid. I had SO4 -2. It's now linked to the zinc. It stayed SO4 -2, didn't it? What happened? Here's my piece of zinc. Let's change the ball. Here's my zinc, okay? This zinc is sitting in here. This is our zinc block, our rod, all right? Here it sits in the thingy, all right? There we go. Now this is one atom of zinc. It's on the solid. I put it in, right? It now drops off the surface to become an ion. It's changed from a solid to an ion, right? What happened? What actually physically happened? How did it do that? Well, okay, if the zinc changed to an ion, there must be 2 electrons somewhere, correct? Because it was a solid, so the zinc, right? The zinc's orbitals were full, right? We had all our protons. I'm not going to go through. We can do it for advanced. We had all of this electrons and they balanced out. The positive was equal to the negatives, right? That was zinc solid. But then what happened? It changed to an ion. So in order to do that, there must be 2 more positives, right? Which means I lost 2 electrons are gone. So 2 disappeared. Because if I add +2 and -2 here, I get back to a 0 there. Zinc is an element, right? The Zn is an element here. Right? Like that. The copper was a +2. It was an ion. All of a sudden, it got 2 electrons, didn't it? Okay? It got 2 electrons, right? Because it changed to the solid. Like that. The SO4 and the SO4 stayed the same. It didn't change. It's still in solution. It's still an ion because in actual fact, it's just hooked up with the ZnSO4. This is called a spectator, an onlooker ion. This one here, okay, gained electrons. This one, this one over here, okay, lost electrons. This zinc lost electrons. It lost 2, right? What did it actually do? It did this. Okay? The zinc popped off and left 2 electrons behind. The copper came, took the electrons and precipitated out. That's what's actually happening, right? At the same time, all right? Let's look at the surface. Okay? Here's one zinc. Okay, he hops off to become Zn +2. He leaves behind him 2 electrons there. They stay. At the same time, copper +2 comes along and takes those 2 electrons, okay, and becomes copper. Because it had 2 missing electrons, it's found them. It's now become copper again. Zn +2 +2 electrons, okay. Left it behind, rather. We put it that way, okay? Okay. Copper gained, the zinc lost. Right? So the total reaction, okay, was actually this. Okay. We said that zinc solid dissolved. So it changed to an ion and it had 2 electrons. The copper +2 electrons came along and it took those. They must always be equal, okay? Electrons don't hang around in chemistry. They link to someone else, all right? And that then became copper solid. It got its electrons back to become copper. Lastly, the SO4 -2 stayed as SO4. It's a spectator. This one gained electrons, okay? There's an old mnemonic here I want you to remember. Oil rig. This means oxidation is loss. Oxidation is loss. Reduction is gain. Okay? Oxidation is loss. Reduction is gain. So what has happened here? Okay? This one has gained. This has lost. So this is loss. This is gain. So this is reduction. This is, whoops, a daisy. This one here is oxidation. Okay? This then is a redox reaction. It's not an ion exchange. Electrons were transferred between each other. In other words, the ion exchange is the whole ion was exchanged with each other. They just changed. It's like 2 couples were dancing, right? This couple is dancing and that couple, and then they come along and switch. Boom. That's an ion exchange. They switched partners, right? Remember, the first one, the positive, and the last one's negative, they moved boy, girl, and then boy, girl moved the other way. The girl from that one went to the boy of that one. Okay, that's another way of looking at it if you want to. Okay, let's just put that in. Okay, with the ion exchange. Okay, let me just put it in. I'm going to put it in red. Okay, we had here. Okay, just get my. We said right, boy, girl, and boy, girl. The second couple, right? In fact, let me change that to a blue. Kevin, let's change it to green. Boy, girl. What do we do now? We go girl plus boy. Okay, and we switch partners, right? And they were reds, so boy, girl. Can you see? Okay, those two and those two went together. Right? Boy, girl, they switched, right? So red boy, girl went to red boy, green boy, red girl. They switched partners. That is ion exchange, all right? The other one that we're doing is redox, which is a process involving a transfer of electrons from one element to another element, right? You can see what has happened there. We've transferred electrons, okay? I have gone way over my normal recording time. But I'm hoping that that's put that into perspective. When we do some examples later on, I'll do a few of them in the test and exam preparation side. But in the meantime, obviously, you're going to be doing quite a lot of them in class as well. Okay? The last part of the work is what we're going to start. I'm estimating 2 tops 3 sessions on that, but I'm guessing 2 will be enough. That is stoichiometry, which is quantitative aspects of chemistry. Thanks for watching. My apologies, I've gone so far over. Cheers.